if I can. Okay, there we go. Making sure all my buttons work. So I just wanted to give you a brief background on the biology of powdery mildew, which is what my technology that I'm using works on. I'm sure you guys are all familiar with powdery mildew. It is a pest throughout any grape growing region, even through hot and low precipitation. It's an obligate biotroph, so it colonizes the surface of fresh tissue on the grapevine, and 95% of its fungal tissue is on that plant surface. So it can infect any green tissue, such as clusters, leaves, and the stems. It can reduce photosynthesis of leaves and render the berries unharvestable. So understanding the biology, how it grows on the surface, can really help inform how we treat for it in the vineyards and how to apply those new technologies. So as I said, that majority of the fungal pathogen is on the plant surface, making it highly exposed to ambient or manipulated environments. This graphic here and that QR code, if you scan it with your phone, will link you to a Good Fruit Grower article in which Charlotte Oliver was the author on that, and she created this really cool picture here that's actually really informational and just describes how powdery mildew thrives in specific environmental conditions, and it really truly is a Goldilocks. It doesn't want to be too cold or too hot. Its optimal temperature for growth is between 50 to 90 degrees Fahrenheit. It likes ideal humidity, so 60 to 90% of that humidity is really ideal for it, but it doesn't need rain. So when you have those thick canopies, that means you have high humidity in that canopy, thus some mildew opportunity. And it is also highly susceptible to UV damage. And so really creating that canopy architecture, opening up that canopy, allowing light into the sun, into that canopy helps it. And then lastly, one indirect influence is cold damage, which creates excess shoot growth and then creates those perfect microclimates for mildew. Again, that link is there. It's a really neat article, and it just kind of goes into specific environments for powdery mildew. So routine fungicide sprays are commonly used for powdery mildew control, even in vineyards with low disease pressure, such in Eastern Washington. In Eastern Washington, we typically spray between 4 to 7 times, and we like to focus those sprays in the early season. So I'm sure, I think you guys have a very similar climate to us, so we probably follow these same approaches, but I'm just kind of going to go over, and that kind of explains why we chose to spray when we did for the UVC light. And so you want to focus those sprays from the 3 to 6 inch shoot growth to 3 weeks post fruit set. And in higher disease pressure areas, or just higher disease pressure years where you have milder temperatures, more precipitation, you can potentially, you'll have more sprays that you're doing. But the aim with any fungicide program is to control that powdery mildew early. And so that is that on the left-hand side, that's that early time. And that is to create, to lower the inoculum source for the most important aspect of grapevines, which is the clusters themselves. And so clusters are susceptible to infection from 2 weeks pre-bloom to 3 weeks post-fruit set. And after this critical window period, generally fungicide applications for mildew can end, as clusters have a very low chance of becoming infected with mildew, but like rachis kind of still remain susceptible. And if you have a really susceptible time, like where you have more precipitation or lower temperatures, after that 2 weeks pre-bloom, you probably would like to spray and continue your program. But in Eastern Washington, around bloom, we get really hot temperatures, so we can usually stop our sprays 3 weeks post-fruit set. But even in lower input management areas, like the one that I'm working in, our current management for powdery mildew still faces one main issue, and that's fungicide resistance. Grapevine powdery mildew is confirmed to be resistant to multiple fungicide resistant action committee, or better known as FRAC groups. And with this growing concern of fungicide resistance, there's a need to look at alternative pest management technologies, such as the one I'm working with is ultraviolet-C light. So what is ultraviolet-C light, or UV light? It is a part of the electromagnetic spectrum and is composed of short gamma to long radio waves. And those that visible light range falls in the middle. And the ultraviolet-C falls right outside of that visible light spectrum. And so the UV spectrum, it contains UVA, UVB, and UVC light. UVA and small amounts of UVB reaches the Earth's surface in daylight, while UVC does not. This is a good thing because UVC light is a short, highly energetic wavelength that is germicidal. And like I said, it's that surface sterilization. It is toxic, or it's not good for us to look at it or have it on our skin. But there's ways to prevent it: goggles, PPE. So having it, it's really good that it doesn't reach our Earth's surface and that we can artificially make it and direct it in ways that we would like. And it does harm us and pathogens because it disrupts DNA bonds, and so it prevents replication in the cell. So it just completely takes that DNA strands and rips it apart. So it really just kills things. So artificial light is not a new technology. It is currently used, like I said, in sanitation for hospitals, water treatment facilities, and it is used in post-harvest storage. And then in the early 90s, early field trials at UVC at Cornell University with Dr. David Godori and Al Michalowski, seen in that photo, they started trials using pre-harvest UVC for powdery mildew. They use that apparatus there. It's really neat. But you can see one thing that's different from that one is it's not an enclosed system. They just directed all of that light right out of that, and they used it during the daytime. And so during the daytime, it needed a really high dose, and that dose to control the mildew, it's seen on that right, it caused that rusting of of berries. So they killed the mildew great during the daytime, but they caused these really undesired effects to the fruit. Pre-harvest UVC light for powdery mildew control in vineyards are just in any application in agriculture that was put on hold. So it wasn't until recently in 2016, there was a scientist who revisited the use of UVC for pre-harvest for powdery mildew on strawberries. The study found that a dark period of 4 hours after treatment allowed for a lower dose of UVC light that would kill the mildew and not damage the plant. The biology behind how powdery mildew responds to UV light was the key to the study and the recent adoption of pre-harvest UVC treatment. So why did that 4-hour period work? Powdery mildews, they have this robust photolyzed mechanism that is driven by blue light or UVA light, which is present during the day. So when that naturally occurring UVB or artificial UVC light, that damages the pathogen, but UVA repairs those cells. So when you apply UVC at night, you bypass this light repair mechanism of the pathogen, and that allows for a lower dose that does not harm the plant, but it kills the mildew. So thus far, powdery mildew has seen recent development in commercial robotic units to treat strawberries and to treat grapevines. And they are producing, it's a Thorville on that left picture there. They already have it out and commercially available. You can buy lights, and so you can get this technology. It's not as far away as we think it is. And additionally, growers do still have concerns about the pre-harvest UVC and how that could affect quality because of this picture here and just past experiences. And as you know, like UVC, not UV, but natural daylight can increase the natural phenolic composition of berries. So there is a worry of UVC light creating undesirable effects. So my research also does delve into the berry quality from UVC exposure. So this is my design that I have. This is how I apply the UVC light. It is the left picture is the framework without any of it. This was welded and constructed by by VineTech, which is a sprayer implement that does vineyard specifically work for us. So they welded this. It's a 3-point hitch over the row sprayer, so it attaches to the tractor, and then it hangs over onto the grapevine. So it's like a housing unit, and I drive it over. The middle picture is showing the lights in there. I used 12 UVC ballasts, and so that equals 24 UVC light bulbs. And again, if you would like to make it intenser, be able to drive faster, you can add more lights. You can really just optimize the UVC dose that you're going for. And then that bottom right-hand picture is me driving the unit. Those are fake lights on there. So we were doing that at desk just to get a really cool picture of it. And it just drives right over. The dose that we are using is 200 joules per meter squared. And so you can increase or decrease that dose by adding more lights to the unit, and so you can drive faster, or having less lights so you drive slower. So really it is speed and how much lights are coming from those. That QR code is some really cool resources to UVC light. We have all of what we use to build it, really just a how to build if you would like to. That unit I think cost maybe $5,000 that we built. Granted, I can't drive very fast with that one, so we're kind of hoping growers potentially will adopt it and play around with them and make the headway of how do we engineer this to be better. But we just want to have it open source, people be able to play around with it, do what they are. But also my caveat with that is wear PPE, and there is information about PPE and how to protect yourself against UVC light in those resources. So to test UVC light, and what my research has been about is, are these questions is, how can UVC light treatments integrate best into Eastern Washington for grapevine powdery mildew management? And we also wanted to know, does UVC light treatments negatively impact berry quality? And to do this, we did different nighttime application intervals of UVC light at 200 joules per meter squared. And that was applied throughout the season and was compared to a standard fungicide program in Eastern Washington for powdery mildew. So on the left is the treatments that we used, and then the products that we were using for our fungicide control. We repeated this experiment in 2020, 2021, and 2022. You can see that there is some different UVC intervals that are different throughout the years. In 2020, we started doing it just once per week, and then every other week, so bi-weekly. And we found that the bi-weekly was not effective, and so we opted to tighten the intervals. So we added a 2 times per week, and then we continue with the 1 times per week, and that was repeated in 2021 and 2022. We have the full fungicide spray, which mainly consists of early on sulfur products, and then we switched to systemic fungicides that have no known resistance so far, and we tried to use some surfaced adjuvants for that, and then we have a complete full season unsprayed. And so all these treatments for all of the years, they were applied from 3 to 6 inch shoot growth all the way to 3 weeks post fruit set. We did disease ratings for each treatment. We evaluated 40 leaves and 40 clusters per treatment replicate. So there's a lot of disease, and then we took a percentage. So how much visual powdery mildew was on that leaf, and we looked at it as a percentage and wrote that down. And then to look at the berry quality, we harvested those berries and we skinned them. We took very basic harvest metrics, so your pH, your Brix, your TA, and then we went and skinned those berries, and we're looking at the phenolic composition of the berry skins. And all of these we did, there was limited canopy management throughout the 3 years as we were trying to create an environment for mildew to thrive. And in 2020 and 2021, we did hedge for the last couple of months so the UVC machine could go over the row, but we thought those wild shoots would damage the light bulbs, but those wild shoots are pretty soft and malleable, and we had no damage. So you can use this machine over really crazy canopy, and it's gonna not harm. Our width for that housing unit was 5 feet wide, and our canopies sometimes they mainly stuck to about 3 feet, but you got wild shoots, and I was really happy to report that it didn't damage the housing like we thought it would. And so in 2022, we did not hedge. We did do shoot thinning as we had some cutworm damage, so we needed to try to reduce some of that because it was a lot in there. But you can see on that all these photos that even with shoot thinning, we had a really dense canopy. And then to give context to the results, I'm going to talk about some weather for these. And in 2020, and so these are, on the left is showing the cumulative growing degree days from April through October. That right graph is a cumulative precipitation, and that's throughout the whole year. And then we have in the blue is that 10-year average. The 2020 was the gray, 2021 was the black, and then 2022 is that red line. And so in 2020 and 2021, we had really abnormally high years. You can see that with the growing degree days. They are just way above that average, and they start off early in the season before over that blue line. So we just had a really jump start of hot days. And then in 2022, we had a really mild year, and it did catch up to everything for the growing degree days by the end of the year. But during the critical window period of those clusters, which is around June, it was really low and mild. And then if you come over to that cumulative precipitation, that red is 2022, and you can see it just jumps up. And so we had a lot of precipitation. So that led for 2022 to be a really high disease pressure year. And then if we go back and looking at those black and gray lines, those are 2020 and 2021, the flat lines indicate that there was no accumulative precipitation. And so that meant in those years that there was no precipitation. So those led to a very low disease pressure year. So we have 2 low disease pressure years with 1 high disease pressure year. And so, and then that is showing the critical window period right there. Again, that red line had a lot of precipitation. So that was good for this year, not for growers, but for my research, just showing that there was disease out there. And then these graphs represent that foliar disease severity throughout the growing season, with 2020 on the left and 2021 on the right. And then the next slide, I will show the results from this past year, 2022. The x-axis is at observation dates from May to September, and the y-axis is the cumulative area under disease progress curve. And what we did is we took all those disease ratings throughout the year that we did, all those percentages, and turned them into how we can visualize them throughout the season. So we're seeing how the disease progresses through the season. Those fun dots there are showing when we applied treatments. And so it just really shows that disease did, for foliar at least, did continue after the disease, but we were able to have cluster control, which I'll show. And it is also important to note the scale difference is different for those years. 2020 was 2021 is 4 times lower than 2020. So we have 2,000 and then 250 on 2021. So that really just shows how low the disease pressure was for 2021 in particular. The difference indicate the letters indicate differences, and those percentages by those letters are indicating the final disease severity ratings for the year. In 2020, while UVC did not statistically reduce foliar disease, shown in purple, and then the untreated is in red, and the biweekly is in green, and then the grower control is in gray, which is down there at the bottom. It did so that UVC 1 time per week, though not significant, it did reduce foliar disease by 25% when compared to that unsprayed. This trend is why we chose to tighten UVC intervals for the following year. And again, moving on to 2021, the right graph, statistically UVC treatments shown in purple and blue, those were not different from the unsprayed control or the full spray, though the 2 times per week UVC shown in the blue did trend towards better disease control than the unsprayed control. So the 2 times per week application reduced disease by 79% and the 1 times by 50%. And though the separation between the treatments was difficult, and those were due to that we just had really low disease pressure for those years, it was promising to see that as UVC intervals tightened, disease severity did go down. So this trend was promising. And then this leads me to 2022, where we had really high disease pressure here. Notice that y-axis is up into 3,000. So we had disease, and we also had disease separation, which is really neat to see that UVC light was doing. While it was still high foliar disease, but again, I want to reiterate, we were really trying to create a lot of disease. And so I'll talk more about that later, but this graph is showing, again, those fun dots are when we were spraying. We did continue on a little later just due to how the pressure or how our weather was. The letters indicate the differences, and those percentages near the treatment labels are the final disease severity ratings. In this past year, those UVC treatments were significantly lower than the unsprayed control. And those 1 time per week reduced disease by 37%, and then the 2 times per week was reduced by 61%. So these were really showing that UVC does reduce those, and we believe that with canopy management and controlling, mildew around you, that you really can control mildew with this, or it can really integrate into a pest management system. So these are showing the cluster disease. We have really low cluster disease in both years. In 2021, we had no disease, though that it was great. Like those clusters were big, and the canopy was big, and there was just nothing. But we had that really bad heat wave that occurred. And in 2020, again, we had like the highest was 5% of disease on fruit. So there wasn't really any separation. This was again due to those high temperatures that occurred in late June. At the same time, at that critical window period, powdery mildew really has a hard time reproducing when temperatures stay above 95 degrees. So this is the 2020, and those percentage numbers do look high. But I have some other cool images to go along with those. But we did have disease separation. The untreated was our highest, and then we have our 1 time per week in the purple, and then reducing it is the 2 times per week, and then our grower control. But it is also important to look at that season long and just like how it prevented it. We believe that we potentially should have continued spraying and treating, because even our full spray, we had some lack of control on there. We did everything in our vineyard to induce the disease, and we believe that cluster disease severity would be much lower with the general canopy management practices. So, and also we had really small treatment replicates, and we had unsprayed treatments in there. So we wanted disease and we got it. So looking at the berry quality for 2020 and 2021, berry metrics were no difference between treatments, and this included the yield, berry weight, Brix, TA, and pH. Though 2020, we did see a difference in the tannins and phenolics, which I'll go through later. And in 2022, seen on that right table, we did have a difference in yield, average berry weight, Brix, and pH, but that was not due to UVC, but it was due to the disease severity. So it is important to notice those visual differences seen in those left pictures. The top left is the full spray, which looks okay, but as you follow clockwise, the disease gets worse. So 2 times per week was our tightest interval. So we were out there every 3 days spraying. It looks better, but definitely that is not acceptable fruit. And then as 1 time per week, once per week, it looks worse. You also get less yield coming through that. So it's just showing that we were able to prevent disease on that 2 times per week earlier, but as canopies got bigger, light wasn't able to penetrate. So that is why we're seeing some yield differences, but not really overall disease pressure in that looking like it. And then the unsprayed, it is horrible. We had just complete berries falling off clusters. You can tell that like powdery mildew was able to infect those clusters earlier, and that's why there was no berry development. That's why there was only rachis on those clusters. So that is why we have those differences. But it is really cool to see that there is a yield difference. So that means we were providing some sort of control early on in the season. And then as our canopies got too wild, light wasn't able to penetrate. Honestly, our spray wasn't able to penetrate, and that full grower spray. So I think this really brings home how important canopy management is in those high disease pressure years. Brix and pH are different, very typical for powdery mildew infection. It increases your Brix because it's dehydrating that fruit. It's increasing the pH because it's also, again, not allowing for full development. So I think this was just a really neat representation on how we were able to control the mildew in clusters, but obviously the mildew won at the end of that year. So now we're going to look at those tannins and phenolics, and they were just inconsistent throughout the year. So on 2020 is the left, 2021 is middle, and then 2022 is on the right. The x-axis shows treatments and then split into tannins on the left and then phenolics on the right. The y-axis is in milligrams of fresh berry weight. And the treatment labels for all grapes are on that top left, following the same color code. Full spray in gray, biweekly in green, 1 time per week in purple, and the tightest interval every two times per week is in the blue. The letters indicate treatment differences, and we only saw treatment differences in 2020. The UVC light 1 time per week did increase tannins and phenolics compared to the full spray control, but that trend was not seen in the 2021 and 2022. So this inconsistent effects led us to believe that pre-harvest UVC light does not influence tannins and phenolics any more than a current pest management program, your synthetic fungicides would do. We were digging into looking at a tighter chemical analysis and identifying the compounds that are in those berry skins to see what happened in 2020 and if there's different compounds that are being expressed in those skins. But with this data, we're fairly certain that environment is playing more of a factor in those than actual UVC light. So while not always significant, the consistent trend in reduction in powdery mildew disease result of 1 time or 2 times per week indicates that incorporation of a UVC light into a vineyard IPM program could be an effective control alternative for powdery mildew management without compromising fruit quality. We believe that with canopy management, we can increase UVC efficacy by exposing the clusters during that critical window time. And just how opening the canopy improves spray coverage, opening up the canopy improves light coverage. And so future research that will continue at WSU under Dr. Michelle Moyer, whose lab I'm in, I didn't say that before, will continue focusing on incorporating those canopy management with UVC light. Though we are pleased with these results, there are some potential pros and cons that must be addressed. UVC light does have some benefits. It's less environmentally dependent compared to a typical spray program. It can be used in winter rain, which is really neat. There's immediate re-entry after treatment. And this technology provides a residue-free option. It uses no water and it can be used when fungicide resistance is present in population. Thus, it does fit into a sustainability pest management program. The cons of this technology are that it is labor intensive. You would need to potentially treat at least once per week, most likely 2 times per week, and that would increase labor. tractor fuel costs. Additionally, it would need to be applied at night. And it is a new tool. It requires either you build it yourself or wait for commercial units. And the effects to beneficial insects are still unknown. So research is going on about the UVC light effects on insects. With that, I'd like to thank everyone involved. All of the funding, which was from the Washington State Grape and Wine Program, help with Cornell University, specifically Dr. David Godory and Charlotte, because she actually was out there one of those years before she started this position at CSU, helping me apply at night. So that was very nice. So thank you, Charlotte. And I'm open for questions. Again, that QR code is the same QR code that I noted on the design and build, and it shoots to a link that has additional UVC resources, recent publications through Cornell University, our paper that we wrote on the design and build of our unit, and that is my email. You can also email me later. But yeah, I'm open to questions. I hope I didn't take too long.
Perfect on time. Actually, we have quite a few questions in the chat if we want to start with those before we get going to actually asking individual questions. Do you want me to read them out to you and then you can just answer them?
Let me look. Yeah, if you want to read them, and I will try to find where I can see them. I see them all now.
So there is one question about the effects of UVC on beneficials. Do you have anything else you would like to add to that? You said it was still undergoing research.
Yeah, so that is undergoing. I'm unsure what the beneficial insects, just from my observations in the field, and these are looking at specific pests. I didn't see any damage, or it wasn't controlling leaf hoppers in our vineyard. They were able to fly away very easily. Moths, even though they were really attracted to our unit, I don't think it killed anything or prevented the moths, because we had cutworm damage after the year when we saw cutworm moths, and they're flying into the unit. And we still had a lot of cutworms in our vineyard. So I don't know if it reduced. Again, we didn't do any studies. I'm working on looking at grape mealybug, again, a pest, and it seems to not be affecting those at the nymph stage. So really, those beneficials that can fly out, I think, are very safe. I would love to be able to really look at some of those, like mealybug destroyers, the aphids that eat other aphids. There is some work that came out of Cornell where they did find that it reduced some aphid populations, specifically aphids that are pests. So I don't have a clear answer for that, but it looks like it's dependent of pest, and so there is the potential that it will be okay, especially if beneficial insects are hiding underneath bark or leaves, or flying out, are there in the grass cover.
Okay, next question. Do you think this technology could be used with table grapes with a plastic cover?
So I believe it could be used in table grapes. I know I'm unsure what the plastic cover is. I know with our Concord table grapes, well, those aren't table grapes, those are just, there's very minimal management to those grapes, and they have that big canopy up top, and then the grapes kind of sit underneath. So we're able to really focus the light underneath, as long as the light can reach the grapes, because I know table grapes and Concords, they typically don't get as much canopy management, as far as I'm concerned. I could be very off wrong, and I apologize, but I think if the light can penetrate, they will be fine, and I don't think it will affect any of the flavors of the table grapes. They have been using table grapes, I think, UVC light after post-harvest for surface sterilization, for then transportation, I believe, in some areas.
Is there any effect on downy mildew?
For downy mildew, they're unsure about that one. There's work coming out of Cornell University. They were seeing potentially a reduction in sour rot or in botrytis, but botrytis is one of those where it gets into the fruit. So if they're able to keep the surface sterile, when botrytis would then inoculate itself into it, they were able to then prevent it. So that work is ongoing, but there is some pretty good potential there, I believe. Lexi will answer them.
So Europe is using UVC during the day. What's the difference between the night application and the day application?
Ooh, so they're using, as far as I know, UVC during the day doesn't really do much because it, especially with mildew, that repair mechanism that I talked about, you need a really high dose. So I'm not sure what they're controlling with it and how that's working, but my understanding is if you get any sort of UVA light after you've responded, that mildew can just reverse the damage done. So I think that it wouldn't be as effective, and maybe they're going out there daily so they're able to just get some knockback control, but really truly that nighttime application is key, just because it bypasses the repair mechanism. You're able to use that lower dose, which is 200 joules per meter squared, and cause no damage to the fruit or to the vine. To a generator.
Yeah, what's your generator watts and tractor miles per hour for application?
Yeah, so those resources, they're there. So we're looking at, I would have to pull up the Excel spreadsheet, but I believe it was like 100 watts, something like that. That was because we have a cool meter that reads the UVC light in watts, and then we convert that to joules per meter squared, which is watts over over seconds. So it's truly a time of dosage. So ours was only going 1 mile per hour. And that was to deliver that 200 joules per meter squared. Like I was saying, if we increased the unit, added more lights, made it bigger, we would be able to go faster with that. So there is the potential to increase the joules per meter squared and the watts that I was getting. And we do have some cool conversion factors for that in those resources.
Will UVC destroy a cervuli from anthracnose? I don't even think you have anthracnose in Washington.
We don't. I think there's actually maybe some in Mount Vernon, the northwest, very top by the Skagit region on the Canadian border. But I don't have an answer to that. I don't believe it would, just because I know that fruiting body does sit into the fruit, if I'm correct. And so it's protected by the fruit itself, and then the spores come out. So maybe the fruiting, I don't have an answer to that. That would be really cool to see. But I think that mildew, or not mildew, that fungi in particular is really good at protecting itself.
For your spray protocol, 4 pounds is 4 pounds per acre for the sulfur application, right?
Yes, it was. So I converted everything from the metric to commonly used for the grower. So that was 4 pounds per acre. Yes, it was.
Do you know the price of equipment for the robot application?
Yeah, it was fairly high, if I remember right. I want to say in like 20,000. And those are still going through some testing still, and they're working with growers to get units out and to like improve what they have. Thorvald was the manufacturer for that one, and I believe they're out of Norway.
We have 2 more questions in the chat, and then we can turn on mics if anyone else has any last questions. Was there a metric for canopy management, like leaves per meter squared or anything like that?
I did not go out and get that information. I have some, I took LAR shadow ratings for that. I don't have those on hand. But I think when we dive into deeper canopy management and then correlating to our control, I think looking at leaves per meter squared are the cool unit where you're putting the probe in and really dialing how big your canopy is would be very key for that. But for this research specific, we did not.
And can UVC create problems for soil microbes?
I don't believe so. Really, our lights are focused in on that canopy. There is some, as you can see on that bottom left picture, that it is like radiating to the floor. We have really, we have natural vegetation on our floor, and we don't have bare soil. So we do a lot of mowing out there. So that in itself would protect the soil microbes. I don't know about bare soil. It would surface sterilize anything, but I think it wouldn't penetrate anything past that first like centimeter of soil. So it could potentially those first top layer, but below it, it should not affect the soil microbes below that.
All right. Does anyone else have any questions? Would you like to turn on your mic and ask them? We still have a few more minutes of Lexi's time before I return you back to your day. So feel free, the floor is open. I think we're doing pretty good on questions. So if anyone has any more, feel free to just pop on or send Lexi an email. I'm really glad that everyone was able to join us today. Please visit my actual website. So we have a few more actual things coming in the next couple weeks. I do have webinars set up from now until basically May. So hopefully you guys can join us pretty much every 3 Thursdays. And we'll have something similar to this. Thank you all for joining us today. It was really nice to actually talk to you, and I will give you back 10 more minutes of your day. I'll talk to you or see you all later.
Awesome. Thanks again for having me, Charlotte, and thanks for everyone for joining.
See ya, guys.